Hello everyone, we are 麦当劳. Team leader is 甘奎成. Team members are 邱敬伟, 吴任辉. Now I will talk about the states. These are the states which are controlled by function select. When function select is 001, the state will be F1. When function select is 010, the state will be F2, and so on. Now I will talk about our algorithm. To input one set of IoT data, we need 16 cycles. There are 8 sets of IoT data each round, so we need 128 cycles until we can perform function calculation. To minimize the procedure time, we will start calculating function at 129th cycle, where 129th cycle is when the first 8-bit number of second round being input. In other words, we input IoT data and do calculation at the same time. Now I will talk about our first function, max. The first function is finding the maximum of 8 inputs. We compare the leftmost 8 bits of first one and second one by comparator, and the output of comparator will have 3 different cases, which are A larger than B, A equal to B, and A less than B. And then we take the 3 output as the selection bit of 3 multiplexers by adding the additional NOT gate after A less than B case. By doing so, the output of 3 multiplexers will always be the larger number, so we use the AND gate before register and then send the number back to the input part to compare with other 8-bit of other input. If we have already compared the leftmost 8 bits of every input and still can't find the maximum, we shall move it to another 8-bit and then compare again. Now I'll talk about the second function, minimum. The second function is finding the minimum of 8 inputs. We use the similar method as before. We also compare the leftmost 8 bits of first one and second one by comparator, and the only difference is that we adding the additional NOT gate after A larger than B case. By doing so, the output of 3 multiplexers will always be the smaller number, so we use the AND gate before register and then send the number back to the input part to compare with other 8-bit of other input. Same as before, if we have already compared the leftmost 8-bit of every input and still can't find the minimum, we should move it to another 8-bit and then compare again. For the third function, average, in this function we try to minimize the circuit area. We separate the summation of the 8 set of IoT data into 64 cycles, which means each cycle will perform 2-bit summation of the 8 sets of IoT data. In the first cycle, we perform the summation of LSB and second least significant bit of the 8 IoT data. The next cycle will perform summation of third and fourth least significant bits of the 8 IoT data, and so on. After finishing the summation, we will write shift 3-bit of the result of summation, which is equivalent to dividing the result by 8. Now I will talk about the fourth function, extract. In this function, we will first let one set of IoT compare with the upper bound and lower bound. In this function, the output must be bigger than lower bound and smaller than upper bound. The output of the comparator will be the input of an AND gate. The output of the AND gate will be the control bit of a register, where the register will output IoT data if the IoT data satisfies the condition of extract. Now I will talk about function 5, exclude. It is very similar to function 4. In this function, we will first let one set of IoT compare with the upper bound and lower bound with comparators. In this function, the output must be bigger than upper bound or smaller than lower bound. The output of the comparator will be the input of an OR gate. The output of the OR gate will be the control bit of a register, where the register will output IoT data if the IoT data satisfies the condition of exclude. Now I will talk about function number 6, peak maximum. In this function, we will first use the circuit of function 1, because in this way we can reduce the circuit area. The output of function 1 will be the input of a comparator, where it will be compared with the previous max and then output peak max. For function 7, peak minimum, in this function we will first use the circuit of function 2 to reduce the circuit area. The output of function 2 will be the input of a comparator, where it will be compared with the previous minimum and then output peak minimum. Now I will talk about known and to be learned. About the known and to be learned issues of the project, we already know the RTL code of our design, but still need to simplify the circuit, and we already know that our design will have low speed, so we need to improve it by adjusting clock. This is our team job assignment. And this is our project work schedule. We will first deal with very low code, and then we will debug. Then in week 2, we will do logic synthesis and optimization. Then finally, we will do a final report and final check. Now I will talk about possible issues and expected solutions. The last part is possible issues and expected solutions for the project. We may encounter setup time and hold up time violation, and we can solve this problem by adjusting the delay of combinational circuit. We may also find that our design have correct functionality, but the area is large, so we need to optimize it. Thank you for listening.